Okay, let's unpack this. We are diving deep into this massive shift happening right inside the IT department. For decades, if you worked in IT, your job often felt like, well, constantly playing catch up. Something breaks, you open a ticket, you wait. It was reactive, a service center just fighting fires all the time.
Yeah, that era is changing and changing fast. What our sources are really showing is this complete convergence. We're talking AI, machine learning, advanced automation, all coming together.
Yeah.
And it's fundamentally transforming IT operations, moving them from that reactive mode into something highly proactive, resilient even. The industrial term everyone's using is hyperautomation.
Right. So our mission today is basically to give you a shortcut to understanding this whole transformation. We're looking at hyperautomation, specifically across, endpoint management, security, recovery. We'll look at the general trends, sure, but also how specific solutions are actually putting this into practice right now.
And the need for this kind of deep dive, it's really urgent. We know security operations centers, SOCs, they face this perpetual information overload, resource limits. They're just exhausted by false positives. So we need to unpack hyperautomation. What does the hyper bit actually mean? How is it different from, say, the traditional automation tools maybe organizations already have? And crucially, why is it so critical for achieving things like instant device recovery or compliance with zero touch? We really want you to walk away with solid, applicable knowledge here.
Okay, let's start with the recent past then, because I think almost everyone listening has probably been burned by a simple script breaking, maybe an API key changed, or a tool was just too narrow.
Yeah.
We had those first-gen automation tools, things like early SOAR platforms. They were meant to fix everything, but, well, they didn't really solve the resource crisis, did they? Why was that?
Fundamentally, they hit a ceiling, a complexity ceiling. See, traditional automation tools, they focus mostly on pretty simple API-related tasks or, very basic script-based actions. And that just limits the scope drastically because enterprise environments, they're rarely that clean or simple.
So they could handle maybe the technical step, like blocking an IP, but not the context around it.
Precisely. That's the key. Real-world security problems, they're complex. They often involve organizational specific business logic sort of woven into the technical process. You might need to automate blocking a threat, okay. But what if that threat IP actually belongs to a critical partner? The system needs context. It might need to wait for managerial sign-off before it runs that script. Traditional SEO just lacked that embedded intelligence, that ability to handle those blended workflows, bridging security and business needs.
And okay, let's say you actually managed to build a complex workflow in one of those older systems. How easy was it to keep it running?
Oh, it was often a maintenance nightmare. I mean, we've probably all been there, right? Spending weeks debugging a simple script just because some vendor updated an API key without telling anyone properly. Maintaining that traditional automation required dedicated development teams. Constant tuning, constant refinement, maintenance. That level of resource intensity, it completely defeated the purpose of automation in the first place, which was supposed to reduce the workload, not create a new dev team.
So, okay, traditional automation,
Mm-hmm.
procedural, limited scope, heavy on resources. That brings us nicely to hyperautomation. We need to define what makes this a real generational leap. What are the, say, three big distinguishing features driven by AI, ML, RPA? What makes it hyper?
Well, if the last generation felt like learning a complex scripting language, hyperautomation is more like having a language model that speaks to all the machines for you. It overcomes those three traditional failings using three key features.
All right, give us the first one. The one that tackles that resource-heavy maintenance problem you mentioned.
Okay, that's radical simplicity. With traditional automation, you had to manually map out every single intricate detail that needed specialized developer skills, right? Hyperautomation, though, it lets users create automations often just using plain text descriptions. You state the outcome you want. The underlying AI engine. It handles all the complex orchestration, the smart connections between different systems and steps. It really lowers the barrier to entry so dramatically. We're talking line of business managers, not just hardcore developers being able to automate workflows.
Wow, okay. Moving from actually coding a process to just describing the outcome you want. That feels like a really fundamental shift. What about addressing that scope limitation, the fact that old tools couldn't handle everything?
That's a second feature, pushing automation to the limit. And what that means is integrating basically every innovative technology needed to cover workflows end to end. It's not just one simple API call anymore. This requires like a cocktail of specialized AI. So for instance, we see natural language processing, NLP, being used for really complex text analysis. Think threat reports. Then you've got computer vision, specifically for identifying tricky phishing images, the kind a human might even miss. And generative AI, Gen AI, that's huge for efficient incident summarization, even threat hunting. And then you layer on robotic process automation, RPA, to handle all those repetitive browser-based tasks or legacy apps that just don't have nice, clean APIs.
So it's like an intelligent ecosystem that can see, read, process data across all these different, sometimes unconnected systems.
Yeah.
Okay. Now for the third feature, the one that gets us past just following a script and solves that problem of needing, say, managerial context or approval.
Right, that's automation with reasoning capability. And specifically, using AI agents. Traditional automation is purely procedural. It just follows an explicit script, step by step. Gene AI agents, though, within hyperautomation, they go beyond that. They can spontaneously tap into vast amounts of intelligence, identify gaps in an investigation, they can reason through alerts, figure out what missing information is needed, and then actually go fetch that data autonomously.
Wait, hang on. That ability to reason autonomously, it sounds incredible, but also maybe slightly terrifying. What are the guardrails on these AI agents? How do we make sure they don't, reason incorrectly and block the CEO's network access by mistake?
Yeah, that's a fair question, and it's the critical difference between just scripted automation and a true AI agent. The system is still absolutely bound by defined business policies,
Wow.
security playbooks, those are the guardrails. But the agent determines the optimal path within those rules. So think of it like this. If the script is purely procedural, the AI agent is more like the smart, junior analyst on your team, the one who notices, hey, wait a minute, I'm missing the firewall logs for this specific time period. I should go fetch those myself. And then it reports back before deciding on the next action. It's this dynamic intelligence, this ability to adapt. That's how IT becomes truly resilient and genuinely proactive.
That proactive filling of knowledge gaps.
Mm-hmm.
Yeah, that changes everything. Okay, let's pivot a bit. Let's talk broad impact. Beyond just catching a sophisticated security alert faster in its SOC, where else does hyperautomation provide really massive tangible value across IT departments in general?
Oh, it touches pretty much every layer of the enterprise stack, and the results are measurable cost reductions, big efficiency gains.
Okay, so lay out the main areas for us. Where's the impact biggest?
Well, first, in infrastructure management, think provisioning, configuration, maintenance of servers, storage, network devices. Hyper automation automates huge chunks of that. The result: fewer manual errors, which is huge, vastly improved efficiency, and much, much faster deployments, even globally.
And what about on the user-facing side?
Huh.
That often generates the most, let's say, volume of pain. IT service management, ITSM.
Correct. Yeah. For IT service management, ITSM, hyperautomation can take over large parts of incident and request management. It handles everything from, automatic ticket creation and triaging to assignment, even initial resolution attempts using chatbots or triggering immediate automated fixes for common problems. This drastically cuts down response times and definitely improves the overall quality of service perceived by users.
Then you have the core mission, right? Security and compliance.
Absolutely. In security and compliance, the system automates things like vulnerability scanning, threat detection, incident response workflows, and even continuous compliance reporting. This significantly shrinks the window of exposure when something bad happens and ensures much faster remediation of issues. I think the major takeaway here, especially for security teams, is the reduced workload. It allows humans to shift away from that constant repetitive triage towards higher value, more strategic initiatives, like threat modeling or proactive hunting.
Okay, so we're seeing efficiency gains pretty much across the board. But let's zoom right in now. Let's focus on maybe the single most fragile, most unpredictable component in any enterprise IT landscape, the endpoint. The desktop, the laptop, the mobile device. When that fails or gets hit by ransomware, all those ITSM improvements suddenly feel a bit irrelevant because the employee is just completely down, right? This seems like where hyperautomation really promises true operational resilience.
Absolutely. This is, in many ways, the ultimate proof of concept for hyperautomation. Because when a device crashes, or it's non-compliant, or, it gets hit by ransomware, the clock is ticking. Every second counts. Endpoint hyperautomation solutions are built specifically for speed and security in that exact scenario. We're talking about the ability to rebuild a crashed or infected PC in minutes. Some sources cite systems that can fully reconstitute a device in well under 30 minutes. Think about that. It basically eliminates most of those costly desk-side visits and slashes user downtime by, over 80%.
Okay. Instant recovery after something serious like ransomware. That
hmm
still sounds a bit like science fiction. How does hyperautomation guarantee complete malware elimination without losing the user's data?
It's about immediate reconstitution, not trying to repair a broken system. Solutions designed for this, like Swimmage, for example, they don't waste time trying to clean up the mess. That's often futile anyway. Instead, they use these rapid recovery methods. It enables a full system rebuild the OS, all the approved applications, the settings, and crucially, the user data restoration, all from a known, good compliant template. And it does this in minutes. Because it's a full, clean rebuild from a trusted source, it eliminates the ransomware instantly, right at the root. There's nothing left to find.
And when you say secure, what does that mean in this recovery context? Is it just about speed?
No, security is baked in. It means the entire process is built on a zero trust architecture. And when you apply zero trust principles to recovery, it basically means the device itself is treated as potentially hostile or untrusted until the automation confirms step by step that it has returned to that perfect, compliant, known, good state. The whole process needs to be auditable too, aligning with the strictest security standards. Think SOC 2, IPI, fixed compliance.
I'm really struck by the operational resilience factor you mentioned, especially thinking about remote employees now. What if a PC is completely isolated, maybe air-gapped from the main network? Can it still be recovered using this?
Yes, and that is arguably the critical differentiator, the thing that truly separates endpoint hyperautomation from older, traditional tools. The system must be designed with an offline deployment method. This means all the necessary files, the configurations, the recovery steps, they're maintained securely right there on the device itself or perhaps on local media. This allows the system to function completely independently of a network connection. That makes it effective for remote workers, field workers, even in totally disconnected environments. And critically, during that recovery process, or even during something like an encryption conversion, the user's data never actually leaves the device. That's a massive security benefit right there.
And I guess this extends beyond just disaster recovery to everyday management too, like setting up new machines, zero touch.
Exactly. It automates the provisioning of new systems based on pre-approved configuration templates. The system can migrate an entire user profile, we're talking data, their personal settings, their approved applications from an old device to a new one, securely. Even if the employee is setting it up from their home office, this capability is what allows organizations to securely support a global remote workforce and finally stop physically shipping PCs all over the globe just for initial setup or replacements.
Okay, and finally, compliance. Let's say an employee's device drifts out of compliance. Maybe they disabled a critical security agent or something. How does hyperautomation handle that scenario?
It enforces compliance automatically and continuously. You can have policy-triggered rebuilds, for instance. These ensure that devices automatically enforce all the required security protocols upon recovery, or even just after a standard reboot if non-compliance is detected. And every step, every action taken by the automation is documented. You get a full audit log, a complete chain of trust. That's absolutely essential for regulated industries. This kind of hands-free provisioning, maintenance, and compliance enforcement is exactly how IT reduces organizational risk and ensures continuous compliance without constant manual checks.
This really brings it all together, doesn't it? We've seen that hyperautomation isn't just, fancier scripting. It's about using AI agents that can actually reason. It's about enabling radical simplicity for users, allowing more people to automate. And it delivers these supremely resilient deployments with full rollback, whether the machine is online or completely offline. The end result seems to be genuine business continuity, really high levels of compliance, and pretty significant cost savings, too.
Indeed. And, the fundamental goal, especially with endpoint hyperautomation, is maintaining the desired state, that perfect configuration. The system is designed to know what a PC's perfect, fully compliant configuration looks like. And then it preemptively fetches, maintains, and validates all the content needed for that perfect rebuild, even if the PC is completely offline when disaster strikes. Which I think raises a really important question for you, the listener, to reflect on. In a world where threats are constantly evolving, how does automating the return to a perfectly compliant state? How does that fundamentally shift our definition of disaster recovery? Does it change it from being a lengthy manual repair job into something more like instant secure reconstitution?